So thank you, everyone, for joining here. We are really excited to have you all here as we dive deep into the exciting world of agentic AI and its transformative potential for MSP. My name is Bappa Ditya. I go by Bappa. I'm the global tech lead for AWS MSP Partner Program. And with me, I have Jing. Jing, would you introduce yourself?
Yeah, hi, everybody. Can you hear me okay? Okay, good afternoon. My name is Jing Ning. I am I'm an AWS Partner Solution Architect org. I lead a team where we're focusing on AI-powered automation and partner AI transformation. This is one of the use cases that we're partnering up with Bappa on. Excited to hear your feedback on this. So hopefully we get a good use case or two for you to see today.
Throughout the next 15 minutes, we are going to dive deep into the exciting world of Gen AI and show you how you can harness the power of AI to not only streamline your operations, but how you evolve your services that you offer to your customer. So we'll be covering a range of use cases and examples that will spark your imagination and get you really excited about the possibilities that lie ahead. So before I dive deep further into the content, how many of you are here AWS MSP partner? Can you please raise your hand? Okay. How many of you are partner but not into the AWS MSP program? Okay, and the last questions. How many of you here have used agentic AI or generative AI to build a MSP use case? Okay, very few. Okay, we should talk, okay? We need to learn what you are doing so that we can see if there is any joint GTA motion can be developed or not. So thank you. So before we dive deep into the real code talk of the session, I want to give some context about the evolution of MSP over the last 30 years. So if you see this slide, there's a 2S curve. So the managed services is not a new thing, okay? But it's really a kind of changing dramatically as with AI and agentic AI. If you see that the MSP started with the standardization in 90s and then moved to LinOps and DevOps in 2000 and 2010. And that was more of a people-driven operations, okay? Labor arbitrage era. But now we are at a very pivotal point. There's a new S-curve getting developed. And it started around 2015 with RPA, process mining, and AI/ML. But the real game changer for this evolution or new S-curve is a generative AI and agentic AI, which you can see at the very top. And it is going to transform how MSP operate in the market today. So the idea here is to not kind of replace humans doing the managed services. The idea is to build a cohesive strategy where human and AI can work together. Next, there can be an n number of use cases that MSP can build with agentic AI and AI based on what you do and what offerings you have for your customer. And here are a few examples. The examples that you have selected here are pretty much production and really delivering some significant impact based on what our partners are telling us. So you can see the AIOps, dynamic runbook generations, root cause analysis. These are very standard and kind of should be automated if it is possible. And this is kind of transform how MSP handle the operations, the day-to-day operations. On the bottom layer, we have knowledge-based management, help-based automation, and smart companion. So this is knowledge base is all about building, breaking the silos because each team have different process, tools, knowledge base, how AI can bring all the knowledge together, and then the help-based and smart companion is going to show you that not every ticket need to go to level 2. The level 1 guy can solve the ticket if they are really equipped with the AI and generative AI solutions. And in today's code talk, we are going to cover 2 of the use cases from this particular slide. Here are some really kind of very compelling data, the early data that our partners are sharing with us. Number one, 45% there's a 45% reduction in average ticket, which require manual intervention. So these all data are coming from our MSP who have implemented AI and agentic AI into the day-to-day operations. But we are still early in the process or early stage, but these are impressive results that our partners are telling us. We also see, number 2, that 30% average cost reduction in the customer, what reported by customer. And this is because the AI is really smart in kind of resource management and automated cost management. Last but not the least, 60% improvement in the empty tier. That means MSPs can solve ticket much faster which in turn helping customer to retain them for the years and improving their customer satisfaction. And when you are achieving all these data, you are not kind of putting all your people doing some basic work, because now the agent can take care of all those things, and your people can do much higher complex work for your end customer. So the first use case we are going to show you today is the AI Ops, all about doing from incident management, event management, and the problem management, how you find an incident and solve it. So think of day in a life of our MSP support organizations. So the red line in the middle, just consider that as a service desk. And your end customers are calling, hey, my user ID is not working, my database is not responding, my UI is not opening, my API response time is slow. Today, what this team is doing, taking all the information and creating the ticket for the level 2 and sending the ticket to the downstream or level 2 or level 3. This is what we want to change. We are going to empower the level 1 and level 2 team with the agentic AI layer so that they can be capable of solving the ticket by themselves, and not all tickets should go to level 2 or level 3. They should fix themselves. And this is what our demo will look like today. We are going to dive deep into this solution. So here's a call flow of the solution that I am referring to. For example, let's say as a MSP, you are managing web applications. And suddenly something broke. And your service desk or level 1 got a call from the end customer that something is not working. So in the demo that we are going to show you, so there is a UI applications where your agent can log in and ask the question, hey, what is wrong? My customer complaining that my application is not working. So then agent will go and talk with there's a supervisor agent who is kind of orchestrating all the specialized agent doing multiple work. The supervisor agent is going to understand the intent of the query that is coming from the end users, that there is a problem, something is not working, and the supervisor agent is going to talk with a different agent to see what needs to be done. And the supervisor agent is responsible for routing, orchestration, as well as remediation. And it is powered by Bedrock knowledge base and all the LLMs. Here is a set of specialized agents responsible to do multiple tasks. For example, some agent will go and do the troubleshooting. Some agent will go and check the CloudWatch alarm if there is something alarm. Some agent will go and open a ticket in Jira platform. Some agent will start the troubleshooting and the remediation. Once it is done, the other agent will go and close the ticket in the Jira platform. So this is a kind of high-level call flow, but I will ask my colleague Jing to dive deep into the architecture and show you the real code that how it is possible.
Awesome, thank you, Bappa. Before we switch laptop to show you the code, I wanted to set up the context over here. So we will see a cute puppy picture that's actually hosted on static website hosting. We got an API endpoint, and that we're pulling random images out of Bedrock Nova. So that's a simple setup. And then what we're gonna do is, by looking at how multiple agents are working together to solve a problem, when we say, now I'm gonna add an API deny policy where the users will not be able to see this cute puppy picture anymore. So instead of human intervention to all of that whole thing, how we can automate it with the coordinated system. So before I switch laptop, I just wanna show, I'm gonna talk through every single of this function over here, but at a high level, I wanted everybody to think through how an AI agent would work. There are 4 aspects of it, right? So you gotta be understanding what the problem is. So we start with how AI understanding layer is. And then with that, we've got to say, okay, I understand the problem. I understand how to route this, what specialist agent to pull. Then the next thing is you got to give enough context or knowledge to say, this is what you equip the brain knowledge to go ahead and fix this. So we're going to go from AI understanding layer to knowledge integration layer. So once you understand what the problem is, got enough to know how to solve it, then the plan execution layer, that's when AI agent gonna transform all of that into actual actions. So those are the 3 things that we're gonna do. And putting all of this together is a workflow coordination. So I'm gonna go ahead and switch laptop to show you the setup. But 3 things I'm gonna do. Number 1, I'm gonna show you the cute puppy picture, show you the API deny policy, and show you how that's added, and it will be trigger a alarm in my environment. So that's the setup. So with that going on, then I'm going to go into the code to show you how the supervisor agent, all the agents work together, step through the understanding, knowledge integration, planning, execution. Then we're going to come back and using we actually built all of this in the Streamlit UI. You can see in the UI with one user query and one click how everything was fully automated and solving the alarm, the API deny policy, update the API gateway, redeploying, and then coming back and close all the ticket. The whole thing, you will see it, and we will see how that was done live after we do the code deep dive. Okay, everybody sees my laptop, right? So this is that static website. Right now, I'm gonna pull, I just refreshed it, show you a random image. It's working. And then I'm going to show you here, right now, I don't have a resource policy to deny or anything. And then I don't have any alarms. So now let's make some real-world infrastructure problem. What I'm going to do is I'm going to come over here and then manually adding a deny policy. Okay? So I'm going to add a deny policy. It's just a quick script. And then it's going to populate and deploying that. When that's done, I'll come back over here. You should be able to see that that's already happened in the API policy over here if I refresh. Okay, so I added deny policy. What's going to happen with this cute puppy pictures if I refresh them again? I should be getting access denied. There's caching happening, so let's come back and try it in the terminal. I have the command over here. Okay, there you go. I'm starting getting 403 error. Over here, I should be getting access denied. Okay, so that happened. It's going to take a while, take a minute or two to have that alarm happen because the threshold is the deny within a minute. So I'm going to accelerate that by manually creating, sending a lot of traffic to the API endpoint. So you see what I'm doing. I'm sending 10 traffic going there. They're just going to generate, we're getting a lot of 403 errors, right? API deny error. So the whole point of me doing it is accelerate the alarm happening. So we simulate what's happening right now. Let's see. It did say wait a minute or two, but I'm going to refresh to see how fast we can get it. While we wait for this, think about if you do have this problem happen, either for your customer or even any website you're hosting. The traditional way to do this is what? You say, if I got a CloudWatch alarm for the API 400 error, I will deploy automation script and then create a Jira ticket and try to solve that, right? The problem with that is it's static. If AWS changes your API, that won't work. It's brittle. And it can only solve that one specific error you have in there. And it's siloed. The systems don't talk to each other. It doesn't scale well. And it's not safe because it's a hard-coded way to solve for that. So today, we're going to show you, instead of that traditional way of doing that, how the automated AI ops would be able to solve that in a much more intelligent and automated way. So hopefully with that, there you go. I got alarm happening. Great. So we have our full setup over here. The last thing I'm going to show you is one UI before I switch to the notebook to show you some code. This is actually the Streamlit UI that we build. I'm not going to show all of this in action yet. I'm going to go through the code, then we're going to show everything in action. So over here, you see how I turned on full automation mode? After we walk through the code, we're going to come in, ask, do you have an alarm? And then with that happening, it should direct me, do you want to create all these workflows end-to-end automated, and it should work if we do things right. Okay, so with that, I'm switching gears to the code over here.
Jing, quick comment on the UI app. So that is the kind of tool you can get your support desk access so that they are not required to call level 2 or level 3 for every issue they get. So they can start the troubleshooting right from the UI.
Great, thank you, Bapa. Is everybody still with me? Now we have our setup. We're going to go into our code deep dive. The first thing, so this is a almost production level code that we're going to publish to AWS, GitHub AWS samples. So you will see that before the end of the year. If you want to be piloting this with us, feel free to talk to me and Bapa this week. We can get you early access for the code itself. But there are 7,900 lines of code. I'm only going to show some key functions over here. So the overall is I'm going to call out the agent-related stuff and why do we do things this way and how did it help solving that traditional problem in a much better way. Okay, so to begin with, supervisor agent. This is where a lot of the core stuff happening that the agent thinks, analyze, and coordinate different agents to work together to solve the problem we just saw. If you have used Strands before, by show of hands, anybody used Strands agents before?
Oh.
Okay, only a small section of the team over here.
So, good.
Yeah, okay, great.
Nice.
So this, if you haven't used that, this is a very easy way to deploy agents, and then you can build it with a couple lines of code, open source SDK framework AWS has for deploying agents. And it has built-in tools, and you can have the native integration with MSP as well. If you have looked at the AWS sample code, GitHub, the Strands, you can easily see the 4-line or 6-line of code. You got a weather forecasting agents ready, right? So that's the context. So we're using Strands over here. Quick thing I want to point out over here with the supervisor agent is, of course, we would have a supervisor prompt. For the interest of time, I wouldn't show you that, but that's really instruction of how would you want the supervisor agent to guide and coordinate different agents to work together. So the model over here, we're using Anthropic, the Sonic model. Okay, so now think about the different layers we mentioned earlier on the slide. Number one is AI understanding layer, right? So orchestrating everything, entry point, this is number one. This is whenever an alarm got triggered or your customer saying, do I have alarm? What's my cost for this account? Or do I have a security issue? Any of that user query, number one, the entry point for the AI orchestrator to start working. This is where everything is. So I do wanted to highlight two things over here. So we're doing two things. Number one, we're analyzing the intent of the query. What is the query is for? That's the first step. Could this help us determine whether we need to coordinate among different specialist agents? Specialist agent, I do mean Cost Explorer, Security Hub, CloudWatch, a lot of the stuff that if we do need coordinated between different agents, this is what we need to do. If you look at that, if secondary services are true, what we're doing with the results is, first, we get the response from the primary agent, primary service, and then with the second one, we are pending the response together, and the results are synthesized through the multi-agent to do that collective response for the next step. So this is very important because we're saying the manual orchestration by the query intent analyzing how many specialists you need gave you the fine-grained control. Think about if the customer wanted to reduce costs with the security finding or improvement, then you're looking at both cost-related consideration and security finding-related situation. You will need to coordinate between those two. All right, so this is how the entry point is. Next function I'm going in is now AI gonna understand the query, right? So we call this analyze query intent. I'm gonna actually pause for a few seconds for you to look at this prompt. The reason I wanna highlight over here is it takes a unstructured text from the query, determine what AWS service you're gonna use, what are the actions requested, what are the parameters we need to extract, what are the intent? We talk about monitoring, security, optimization, troubleshooting, and what are the priority level, right? So these are setting in the context of managed service provider. You're managing a lot of customer account. You got a different security level. You got different problems. So it's intended for that large scale operations. But what's most important here is we are forcing a format in the JSON format. So this is less error prone. So it forces AI to take the unstructured text, not only understanding what it is, but print out a machine actable steps over here. So all this are stored in the JSON format. Same thing with how you're trying to understand all of this query intent. This is number one I wanted to emphasize. Number two is, remember I mentioned to everybody, we wanted to push this to near production level. So a lot of fallback or resilience were built. If this JSON format, we couldn't parse it, then we default back to the keyword analysis. If customer says, I want to do customization, you go there. Okay? AI understanding layer. I'm going to continue. So now AI got customer or user query, understand, analyze what they are, then the multi-agent orchestration got to happen so that the supervisor can coordinate the different actions to say, you go here, understand cost. You go here to figure out the CloudWatch alarm happening. You go here, create a Jira ticket, right? That's where the action needs to happen. So this is multi-agent coordination with context enhancement. When I say that, I'm going to show you in the code, but two things to look out for here. Number one is the supervisor agent isn't just doing simple routing, saying, okay, this user asked for cost, go for the cost explorer agent. It isn't just for simple routing. While it routed to that specialist agent, it's actually enhancing it with more context. So I'll show you in the code what I mean with enhanced context. Okay, two things I want everybody to pay attention to. I keep using Cost Explorer as an example because that's the use case to Bapa going to demo in a little bit. So in any time you do a cost spending for any of your account, then time is a very important parameter, right? So this is if the agent is Cost Explorer, I got to making sure all of the time parameters were extracted and the query, both on the time parameter and the query intent were passed to that agent together with the enhanced context. Same thing, this is very, very important. I'm going to show this right away, is we talk about specialized agent. We talk about, the agent is able to make intelligent decision, or sometimes even better than human, because we wanted to have those agents have fresh live data. So in this case, all the primary services we're getting from this analysis, when we were routing to specific API operation actions, that's super important. We're actually using AWS documentation to augment it so that it is precise, it is up to date, and it is accurate. So I'm going to go show you exactly how that piece is done, but this is where we use MCP server. So this is, just to recap, when we do multi-agent orchestration, not just simple routing, when we route it to specific agent, we gave the right context over so that agent can get informed response back by considering live AWS documentation and any other contact that are critical for that action. All right. Before I show you how the AWS documentation MCP servers are being used, this is important for the context of managed service provider. I'll do a quick intro here because not many of you guys are managed service provider. But if you are, again, the context, you're managing a lot of customer account. There's a lot of complexity, things at large scale. It is super important to have the credential management in the multi-tenant environment set right. So this is just to highlight, again, when you do get the specialist agent, you can take a quick look over here, but the idea is if you're doing Security Hub or Cost Explorer, those are the customer credentials, the session we need to pass it along to the agent. But if you're doing Jira, like in our case, we're acting as MSP, managed service provider. We own all this Jira ticket, create troubleshooting and solve issues for. So the credentials should be MSP credentials. So this is just to show that how the code level are able to do the credential isolation so that you got the right customization with the right credentials passed to the right agents. It's not universally the same. It's either customers or your MSPs. Okay, so we had AI understanding. We said for routing execution, we're giving enough context. This is where the knowledge integration layer is happening. I'm moving on to next function. Okay, maybe I'll do a quick pause, let you read this for like a quick 1 or 2 seconds. As you read it, I'm gonna highlight why are we doing this. This is a tiered document access strategy where the primary path is MCP client will understand those AWS documentation APIs because you wanted the data to be fresh. You wanted to, every time we push API update, your agent understand that, execute it without any issue instead of hard-coded that way. But again, this is a production level system. So in addition to the AWS Knowledge MCP server to search for documentation, we also have a local cached documentation helper. So if you know your customer or this set of customer environment always have this similar set of issue, you can always have those service-specific documentation in an S3 bucket or locally you cache it, right? So this is a tier strategy. Primary is MCP server. Fallback is the documentation helper. Again, you always want making sure your agent have the right knowledge integration instead of going rogue by itself. Quick plugin for the AWS Knowledge MCP server. Again, if you haven't used it or explored it, if you go to GitHub/AWS Labs/MCP, you'll see all the available MCP servers. If you haven't used it, you should give it a try. Take a look, explore, see what's there. In this case, we're using the documentation MCP servers. All right. So AI understand customer query, understand routing, how many services do I need, what specialist agent I pull, and then we route it with the right knowledge integration. Now, we gotta plan this and execute. So the next function I'm going in is remediation plan generation. This is a super long prompt over here. I'm gonna let you read it again. Then I'm gonna do my highlight over here. So this function is generating a remediation plan from the knowledge-based results with the supervisor validation. So that I really mean it. I'll come back and pointing on why we need those two focus over here. But high level, you see what we're doing here, right? So we take that alarm context, we take that knowledge-based results, and then we say, based on all you know, generate a API operation that AI agent can execute in this context, fix the problem. Sounds straightforward, but two things I really want to highlight over here is the safety guardrails over here. So number one, you see this exactly. In this case, we say, extract only the operations mentioned in the knowledge base. This is super critical. Think about it. Again, you don't want your AI to start hallucination, do a bunch of things you don't want them to. You're gonna have the right boundary. In this case, is a knowledge-based constrained AI automation. In our demo, we are allowing, of course, API gateway updated the actions, and the service names are related are API gateway, EC2, RDS. In your actual environment, you can customize this, of course. Again, you can customize it per your customer, right? So if this set of customers, these are the resources, these are issues you usually have, then proven procedure you want to automate, have that pass in the knowledge database. What we wanted to happen over here is when agent generate this remediation plan, it only does the ones that are allowed in the knowledge base. You may want to ask, what if it doesn't? So in this case, our setup is if it doesn't, you'll just still create that ticket and route it for human intervention. It doesn't do any automation on your behalf. The question is, we have a lot of specific details. How would a person, when we build it, need it to? They don't need to. You can start with literally with one line. So this one I'm showing as in how much safety you can put it there in terms of having AI push the boundary or not, right? So you don't have to start there. You can start there, literally extract only the API operation, AWS operation mentioned in the knowledge base. You can start with the resources. You don't need to be this specific. But I'm highlighting here for the sake of the demo and for the sake of making the point of how when people say hallucination or issues or accuracy, a lot of the time is still because we have to guide it the right way. So this is one way of guiding it. I'm gonna make my second point. I know there's probably more questions. Believe me, we'll have questions because when I do the demo, we gotta wait for something. So we'll have questions. Let me finish the second point. It's important to think about this as in same thing, right? You want it to be safe, reversible operations. If you could just say never delete anything in my customer environment. That's probably obvious. But again, in this world, depending on how you set it up, you may or may not be able to honor that. So I wanted to highlight the way when you wanted the AI agent to generate remediation plan, you can customize it per customer workload or common issues. At the same time, you really want to making sure what is the boundary. Like, do not ever do anything irreversible. So those are very important. So I want to highlight over here. This is the additional details in the actual code I'm not showing here is, again, there's another layer we put in. So we said search knowledge base results, right? There's a confidence score, a relevance score. There's a threshold you can put in there. So in this case, is anything more than 0.5. So if you're not confident about what you're finding this issue is, the relevance for your knowledge base, then don't execute. Again, as an organization or as you deploy your application, you're working customers, you can dial that back and down. I always start with being super restrictive with the AI agent to begin with, and then as you scale or you deploy more and have run more workflows with your customer, then you can allow more flexibility once you got the AI accuracy and the trust with customers. So that's just a nuanced way to say there's multiple levers we put into the code where you can, when AI agents generate that remediation plan, there's a lot of layers you can put in terms of guardrails. In addition to the built-in guardrails you can use in Bedrock and all the other stuff. Okay, so we got the knowledge integration. We generated the remediation plan. Last step, execution, right? We're at the last step, execution. Here, the only thing I want to emphasize again is safety mechanism building. Every single step, we got to go through validation step function. Every action is logged. Every result is captured. And if something goes wrong, we stop immediately. Again, you can dial back and down on the spectrum of how you wanted to do this. But I'm showing you our recommendation, why we do this way. You don't have to read all this code here, but this is literally to show you if you want a complete audit trail, in addition to whatever building in the AWS environment, for the agent itself, for agent action, every single step is logged here. And if anything goes wrong, we stop. Only thing I'm going to highlight, 2-word over here. There you go. Validation step. That's another function. Before agent execute the action, the remediation plan from the last function, we ask the supervisor agent to validate it. So at this point, if the supervisor agent says no, reject, then it still won't execute. Again, that's another layer of check on, are you doing something potentially dangerous in the customer environment? Do I want you to do that or not? A lot of this consideration because we're trying to look at in the product level, production level, how this would look like. Okay, so production grade execution with multi-layer safety validation. The question was, when this last validation step got rejected by the supervisor, what do we do? Do you bring human in the loop to do that, or do you further push it to send another loop to further automate? The answer is depends. The answer is depends. In this code repo we have, this is when we still create the Jira ticket and route it to SME review. So that's how human in the loop were brought in this code. But in some other production level agent that we've done for other use cases, we actually done the secondary, the branching logic, right? So this is the initial set of automation I trust you to do, and then I branch off when this get rejected, and to further analyze, have finer control to see why it got rejected, whether we allow more flexibility to further advance on your automation journey. Okay.
Jump to the demo.
Yes, let's see. One last thing I wanted to show you before I show you the demo is think about what we just did, right? So we said, the supervisor agent is awesome. It's used Strands and it takes prompt. It does a lot of nice, fancy things. But think about our workflow. What are we doing? We needed a CloudWatch agent to detect alarm. We need to create a Jira ticket. We needed to, route it to the right agent. We need to search the knowledge base. We need to generate remediation plan. We need to execute it. And we need to come back and close the Jira ticket with all the comments you've done so that we have logging. So all of this requires a persistent state sharing between all the agents instead of simple routing. So that's the last function I'm going to show you, if I can get my password. We actually use workflow graph that's also in Strands to coordinate different agents with this multi-step operational processes by building nodes and stuff. So I'm not going to show you the exact code, but these are exactly what's happening. We're actually adding the Jira, the knowledge base remediation and closure, all this together so that collectively this workflow would have shared memory and state between the agents. So you don't forget about which ticket am I solving for which customer, which step am I, which remediation did I do? Again, complete that large scale, managing multiple customer account in the environment that you needed both tenant credential isolation, but also clear understanding on what states all that ticket is at. Okay, so that is all for the code. And then I'm ready for some live demo with you guys. Okay. What are we going to do is I'm actually going to send a couple of more alarms just because, we talked 20 minutes on the code, and maybe the alarm is not there active anymore. So I'm going to trigger some alarm and wait a little bit. We should be able to see that. And then I'm going to set up I'm going to set up the UI, right? That Streamlit UI, I want to see how it looks like when you have an operator on that, literally how fully automated it is. And then 2, I'm going to show you my terminal of this code. Then you can see in the back end how the different steps of agents are walking through, again, every single function, pretty much all the function we just talked about. Okay, so I'm going to come up here. Let me set this one up.
I'll show you into that.
Yeah, so I'm going to get the 2 windows open. And then I needed this one. Okay, so if I don't get throttled, I should have this demo. And what I wanted everybody to do is to watch both windows. Again, this is what I ran earlier, right? So you would see in the back end how agent is doing what, the logging, all of that. And this is the front end of how, again, an operator could easily do all of that for your customers. So hopefully we got our alarm. Yep. And then let's see. Do I have active alarms? It's thinking. Okay, I do have an active alarm. This is the API deny policy that we created in the beginning. So it says full automation ready, click to execute. Okay, let's give it a try. Exit full automation. Pay attention to the steps on the left and also steps on the right. Okay, I'm making sure you can see this window. There we go. Creating Jira ticket. See, it has including the issues in there. And then finding my knowledge-based results. I think we found a relevant score of 0.85. That's considered good. I'm going ahead. Right now, I'm executing it already. 2 steps. Approved by supervisor, step 1. I think is update my API. And second is redeployment. Did that go through? Yeah, it did go through. And then last thing, we're going to come back, close the Jira ticket, and then paste all the comment over there. So it actually, oh, there you go, voila, nice. Our live demo works. So let's take a quick look. What would you look like will be a actual, this is a Jira ticket. Of course, I have it earlier there for you, but this is what you would see. It opened it, and it automatically closed it for you with the right comment saying the alarm, what was used, whether successful, what did I do, complete audit trail for you. Okay, great. So that is our use case number 1.
Okay, let's go to use case 2.
Yes.
Okay, wait, it's not.
Yeah, this is good.
No, but, oh, okay, yeah, go ahead.
Okay, use case 2, Bapa gonna show a code deep dive and a demo as well. But use case 2, think about it. We just showed the alarm, watch how it automatically do all that. Another common thing our customer, if you work with a lot of customers at MSP, is cost optimization. Like figure out what my costs in my environment last month, and then go figure out ways to right sizing and optimize all of that going forward, right? So smart companion. I'll do this super quick. So really, the idea is we wanted the AI agent to serve your customers. The way you build it would be, in addition to do a simple query, answer a question, right? That's like a last year tab. That's ancient history. Instead of doing that, it's able to, again, have the right knowledge, knowing this is a customer account that I'm doing, I pass the right credentials, I'm able to make informed and accurate decision for the customer or recommendation. So this way, you can free up your human expert for more complex challenge, having AI agent to help you do a lot of that. The call flow, I'm not gonna belabor the point. It's the same, guys. Now, if you look at this call flow, it should be a little familiar from we just walked through, right? User come in, you have that UI, but user come in, there's routing, orchestration, stuff you needed to do. And in this case, instead of sending into different agents, instead of the Jira and CloudWatch, is what? Is your cost explorer. And then how is using the, again, live documentation API to find right API to use and do all of that stuff with the recommendation and all of that. It's very similar. And then if that's the case, Bapa, you wanted to do a quick code snippet?
Yeah, can you just...
Yeah.
Yeah, so one thing I just want to highlight here. So this is one of the examples that we are presenting on a specialized agent, the Cost Explorer agent. Similarly, you can do the same thing for security agent, trusted advisor agent, anything. The logic will be the same. The code that we are going to show you will be the pretty much same with some little kind of adjustment. And that is what I am going to show you.
All right, ready for demo?
Yes. So again, let's understand the call flow first. So as a MSP, a level 1 team or help desk, your customer mentioned, oh, my cost is really high. So you are not required to go and open a ticket and work with the FinOps team, right? So you come to the UI agent, like a UI, what Jing was showing earlier, and then you put that query, what exactly you need to know. Then the request will come to the supervisor agent to understand the intent of the query, what exactly the MSP level 1 team want to know from the transactions. Once the supervisor agent know that this is a cost-specific request, then it will go and talk with the Cost Explorer agent. It will select the Cost Explorer agent to do all the analysis, to get all the APIs, and then do the API call, get all the information and everything. Then it will come back to the supervisor agent. The response from the cost agent will come to the supervisor agent. And then they will formatting the response through the LLM, make it beautiful so that the end user understand all the kind of cost and so on and so forth. So this is the overall flow, how it looks like. So let me cover some of the core component of this flow. For example, core dependencies import. I'm not going to cover that. This is very standard. like a prompt configuration. This is the prompt configuration, what exactly you want the cost agent to do, right? So use business language, use some emojis, whether it is your cost going up or going down. So a lot of things that agent can do. And it is all part of the code that we can share with you. Next, class definition initialization. This is also a very standard process. I'm not going to dive deep into here. Jing already covered that. And then we do a quick connection testing to make sure that supervisor agent can talk with the cost agent, cost management, and cost management agent can call the AWS API. So the connection is working. So we do a quick test with a very minimal single API transaction. Now, here is the main entry point, as similar to what Jing was sharing earlier, the query. This is where the users is calling this cost agent, cost management agent through that UI interface, that what is my cost for the last 12 months. So this is the entry point, and it is landing into these functions, the query method. So here, what is happening here? So here, the supervisor agent is trying to understand the intent, what exactly the users want to know, whether it is a recommendation kind of things, whether they want to understand the cost anomalies, or whether they want some kind of recommendation to optimize the cost, or this is a very standard user request on the cost management side. Then, if you see the code here, so basically, recommendation, optimize, save, they are looking for that keyword in the query. If the keyword matches, the recommendation matches, then the recommendation, they have a different subsection. Like, okay, should I recommend my cost? Should I get a SI or the RI or savings plan? Or should I go and change my instance size? So those kind of recommendations happens here. And then there is a error handling process as well. Now, what this query is doing, now the query understand, the supervisor agent understand what is the intent of the query. Now it will go and call the repo where we have all the API informations. So once I share the code with you, you will see there is a Python file, which is like what Jing was saying earlier, is a repository of all the AWS API documentations, so that it is not hard-coded in the code. So now the supervisor agent will go and read those kind of API information from that doc helper, and now they will understand that these are the available APIs. Now it will come to the next step. Now for the cost management, what is the right selection of the API? Which API they need to select from that particular repo? It is happening in the section number 6, API selection logic, service-specific API selection. So you can see here, the first thing it is doing to understand that what kind of action the agent should do, whether it is a recommendation, whether it is a cost anomaly, or it is just a cost breakdown per service, per geo, per regions, based on the intent of the query. So it will do the selection of the best API that matches the intent of the query. Now, you can see here, as I said earlier, for the recommendation, we are further going into the details. If it is a right sizing kind of requirement, then it is selecting the get right sizing recommendation API. If you see here. If it is a cost savings kind of request, it is selecting the cost savings purchase recommendation API. Or it is a reserve instance kind of recommendation, it is selecting the reservation purchase recommendation, whether RP or SI. Now, similarly, if it is if the request is based on anomaly detection, it is calling the get anomalies APIs. So based on the intent of the query, this particular function is calling the right API from the repo. So here's a real-world examples, like how can I save cost on my EC2? Let's say this is a query that came from the end customer. So basically, it is detecting what is the keyword here, save, EC2. So that means it is matching with the right recommendation API. So it is calling that particular API because it read the keyword from the user query. In example 2, show me cost anomalies. So that means it understands the customer want to know the cost anomalies. Now it is calling that particular API, which will help to get all the anomalies information. Third example, what are the top spending service? So basically, it is asking, okay, show me all the services from the cost perspective for that last month. Now, it is a get cost and usage report, kind of very standard API, default API, which is also acting like a default API. Number 7 is a customization. Here, we need to understand the user query that is coming through the UI interface is a natural language. So but here, what the agent is doing, it is putting all the right parameters so that it matches the AWS API format. Because the natural query that is coming from the UI is not matching the API format. This is exactly what this part is doing. It is taking all the natural query that is coming as part of the UI interface, and it is converting into the format that AWS API matches, so that AWS API can go and put the right information to the end users. So you can see that, for example, line 9 to 10, it is showing the date. For example, the customer might say, OK, show me the data for last 30 days. What the 30 days means? So AWS API will not understand what the 30 days means. We have to convert into a date time format. So that is what exactly this is happening in the line number 9 to 10. He's setting the time period. It is setting the granularity, whether you want on per day basis or per month basis, depending on the time frame that you are giving. For example, if they want to know, OK, for the last 1 month, it will give per day granularity. If you say per last 1 year, it will give per month granularity, because it will be too much data if we do per day. So this is what the example look like. So all the input that came through the UI interface, this is what the customization is done. I mean, the transformation has been done. So it exactly match what the AWS API can understand, because it converted all the natural language into the AWS API format. This is the section on time extraction. So basically, as I said earlier, any query can come, OK, show me the cost for the last 30 days. So what the 30 days means? So AWS need to understand. So it will do the extraction, that how the calculation will be done. 30 days, convert into a time date format so that AWS can understand. Next, this is the real API call happening here in the section 9. So what it is doing, so there are 2 files that when you get access to the code, you will see. So one is executor. So now this function, this base.agent.py, this is a kind of Python agent, Python code, which is doing the actual API call. So the query is calling this function because this function has access to all the API information from the docs helper. So there is another file which is listing all the API information, and this file is using the repo to select the right API. Now this is the one calling the API, directly API call to understand what information they need to pick up from there. And this is what AWS returns, something very similar like this, based on the query. So this is the format that the user will get once the query get executed, and the API call got executed. And how it is executed, Jing already covered that with all the secret manager is there, storing all the credentials, because it is assuming a cross-account role so that it can log into the customer account, fetch all the information, and storing in the secret manager. Whenever the agent wants to call the AWS account, it is taking the data from the secret manager and then making a cross-account access. Now, the last thing, number 10, is formatting the response with LLM. So if you go back to the previous diagram, you saw that under the supervisor agent is powered by the Bedrock and all the LLMs. Now it is formatting the response. Now, whatever the AWS is responding back, this is particularly converting to a nice response which the partner customer can understand, or any non-technical people can understand. Okay? So this is how it looks like. Beautiful formatted response that are coming from AWS through AWS APIs. Now this function is converting all the API response into a nice template that go to the end users. So to recap, this is the kind of flow that I just talked about. Let me go through a live demo, okay? Again, the same UI what Jing was showing earlier. And now what we can do, we can go here, and this is something the cost explorer kind of examples, okay? Now let's say that this is a user query that what they want to know. Show me the cost trend for the past 6 months. So this is the kind of information is landing on your help desk team, and your help desk can get the information to the end users. It doesn't need to go to the level 1 or level 2 to get the information. They can do it by themselves. Okay, perfect. So I'm not going to the code part because Jing already covered how that happens. So this is the response coming back from the AWS. So based on the query, and this is how it looked like. So all the functions that I just described, 1 to 7, it is running in the background. And this is how the response will look like in the UI interface, how this code. This is very similar, like this is an example of cost management, but if there is similar requirement for security, trusted advisor, everything can be done through a similar kind of template. And the code that we will be sharing, it has access to all the different agentic code, and so that you don't need to build anything from scratch. You can get a very solid foundation, and then you can customize based on the need that you have. One of the reasons why we are having this session, I think we have only 3 minutes left. One of the reasons why we are having this session, because the early feedback from the partner after getting all the responses from the customer, the partner was very impressive. So now the partner, the customer came to us with 2 different options. One set of customers, partner, they said, I want to build everything natively with my in-house resources using AWS services. I don't want to buy an ISV platform. So this is the kind of solution for the partner or the customer who want to build everything in-house. There are other set of partner customers, they said, okay, I want to get AWS guidance on a vetted ISV solution that can do the work for me. I don't need to build all those things. I need a solution from the market that can do that things. So we also have a program called Benefit, where we are telling the partner, these are the solutions that you can buy with the agentic workflow embedded there. You don't need to build anything like what we have presented right now. And there is AWS funding available for them to go and offset the license cost for the partner in the MSP program. So if anybody here want to part of the MSP program, but not yet, and want to try these things, you have 2 options. Get in touch with us so that we can share the code with you, and you can customize the code the way that you feel fit for your environment. Or if you believe that I don't want to deal with the code, I want to buy an ISV solution, you should become an AWS MSP partner first, and then you get access to the AWS funding, so that with the funding, you go and buy the tool that you want. And the tool that you want should be part from our recommended list, because we are doing a selection. We are vetting the solution that this tool actually do the work that we believe the MSP should be doing. And then from that list, you can buy the tool and get the funding, use the funding from AWS. Any questions from anyone? We have 1 minute left. We will give you early access. So as Jing mentioned, yeah, go ahead.
GitHub AWS sample code before the end of the year, by the end of the year. But before that, if you want an early access and be a pilot, talk to any one of us. I'm going to show you that page right now where it has our contact info. But before we close, I just refreshed that. We saved the puppies. The cute puppies showed up. We were getting access denied. AI solved it for us. And then the API policy, the deny policy we add were removed and things were deployed. For closure, that's what it is. And now for contact info, where you can reach out to Bappa and me. Those are our LinkedIn barcode. Feel free to connect. Find any one of us for the next couple of days where we're here. And most importantly, please do a session survey for us. If you like how this talk is, please give us feedback over there. And you're doing the mobile app now, I think.
Yes.
But those are the LinkedIn barcode for us.